Hey everyone, this is Dr. Anna. This is the second segment of the rock fossils in time, and we're gonna continue with the second segment of that module, and we're gonna start talking about sedimentary structures. In physical geology, we already have learned about the sedimentary structures, and if you haven't taken physical geology, it's important that you go back to the Geology 105 YouTube videos and find the sedimentary rocks and look at the sedimentary structure, because that I went through in details and I don't want to redo that. So here we are, sedimentary structures. The sedimentary structures are larger features in sediments that are forming during the sedimentation or very, very shortly after, possibly right before it will lithify. Lithify means that the sediment becoming sedimentary rock, so it won't be able to change too much anymore. This is extremely useful. It's a very important ladder in historical geology, because without this, we won't be able to do detailed characterization of the sedimentary environment. So let's jump in. The first one is going to be the layering. Remember, we also called it bedding or stratification, and that is how the sediment is depositing, and between layers or beddings or strata, you can see a surface, a bedding surface, which separates different layers from each other. Like in this case, on this picture, you can see very uniform layers or varves, which are formed in glacial lakes. There is an interesting thing right here, you see? This messed up area here is a very typical soft sediment deformation, which can relate to a seismic event like an earthquake, or it could relate to some other bioturbidity, means like biological things were moving around there. So it's also a very interesting thing which gives us more fact about the sedimentary environment. So this is what we just talked about right here. When something like this happens, that just means that the sediment is still unconsolidated, which means it didn't become sedimentary rock yet. The next one is the mud cracks. The mud cracks will happen when you have clay sediment. It's in an area which can get alternating between wet and dry. Means that you are, let's say, on the tidal plane, like on the beach, and when it's high tide, it's underwater, and when it's low tide, it gets dry and makes this typical mud cracks. This is a really pretty mud crack from Blaze, and this mud crack was very present day environment, where on one side I could see it underwater and on the other side I could see it dry, and you can see the mud cracks pretty good. And then later the mud cracks are being filled out with sediment, and that's how they get preserved. On this slide you can clearly see how the mud cracks are being preserved. During the high tide time, from the water, the sediment settles in between the cracks, and then it fills it out, and that's how it becomes preserved in the rocks. Now the next one is the cross-bedding, and this here is showing you a typical beautiful cross-bedded sandstone from Zion National Park. You can see the layers here, and here are the cross beds. That just means that this whole area was formed by aeolian processes, which means that the sediment was carried by the wind. It was a big desert because this is the Navajo sandstone, and it formed during the Jurassic 190 million years ago. And at that time, it was such a huge desert, and it was just sandstorm after sandstorm, and that's how these layers formed. Sometimes the wind direction might have changed here, like the angle between the layers is a little bit different, and that just means that the wind direction has changed some. That's another really nice example for cross-bedding. This is also aeolian. You can see the layers right here and see the cross-bedding itself between the layers, and they change somewhat direction. So typical wind carried cross-bedding on a big, huge desert dune fields. And this is at Canyon du Chelly in Arizona. The next one is the ripple marks. So if you look at the side view, which is this, then you will see the cross-bedding. And if you look at the bedding surface, then you see the ripple marks. In this case, this is the crest of the ripple mark, another crest, and as you can see, it has two sides. One side is longer. That's how the wind carries the sediment. I mean the current. It could be wind or river. And this here is short. Long side, short. Long side. And the long side will always tell you about the direction of the current. This is unidirectional, which means it's going one way. And it could be river or wind. So the river is the fluvial and the wind is the aeolian. Normally the wind currents are much more irregular. The thickness of the layers can be different and the wind direction also. When you have river, those are more uniform layers and the crossbeds are exactly the same angles. When you look at the ripple marks on the surface, the bedding surface, they are asymmetrical. One side is always longer, the other side is shorter, and the long side shows you the direction of the current. So it's really good because when you look at the paleo environment and you see ripple marks, you can tell which way that river at that time of formation was moving. So that is amazing data which you can get from your paleo environments, basically. Okay, the other one is the so-called wave ripples. When we have wave ripples, that means that the current goes back and forth. So let's say it's characteristic on a tidal flat, tidal area, tidal flat. Basically, the tide is going in and out, in and out. And in this case, the ripple marks, as you can see, is going to become symmetrical. So if you look at from the crest, both sides is about the same. Here is the crest, both sides is symmetrical, crest. Both sides is symmetrical. So you know that the current is going back and forth, bidirectional. It's easy to tell these ripple marks apart. I have a couple of examples right here on the next slide, so let's see. This one is a typical current ripple. If you look at from the side view, you see that one side is much longer, other side short, long, short. So the current direction shows by the long side, so you know it was going this way. It's unidirectional, and the ripples are asymmetrical. Now on this picture right here, we can tell this here is the long side, short side, long side, short side, long side, short side. So what was the direction of the current? Remember, it's always the long side which shows it, so it was going like this. That was the current. Okay, the next slide showing you wave ripples. So if we look at it here, that's symmetrical. This side is the same as that side, and here is the crest in the middle, and they are symmetrical, as you can see. Crest, middle, crest. So you can see that they are symmetrical, so it's typical wave ripple. Means the current went back and forth. Tidal flat environment where the tide comes and goes in and out. And this one here, again, a typical current ripple. You can see that it's asymmetrical. One side is longer, short, long, short, long, short. So try to do the current direction. And as you can see, it's typical current ripple. And it's from Cambrian, so it's really, really old, from Alberta. Cambrian means it's 500 million years old. And we can tell which way that paleo river was moving, which is pretty amazing if you think about it. And that's a beautiful wave ripple. See the crest in the middle, crest, middle, they are symmetrical. Typical wave ripple means that the direction was bidirectional. So it went back and forth, most likely a tidal environment. Okay, the next one is the graded bedding. The graded bedding means that you have repeated beds in which each bed has the coarsest grains on the bottom and the finest grade on the top. So that's what we call typical graded bedding. So in this picture, you can see this is already the next layer with the coarsest grains, so coarsest. And as you go up at finer and finer, and this is the real thing. So really the coarsest grains are right here. So this line is not so good, and then the finest is right on top, right there. How these layers are forming, if you have like a shallow marine environment and you're close to the slope where it goes into deep water, and there is like a seismic activity, like an earthquake, then all the sediment in the shallow marine environment gets messed up, you know, it becomes a turbulent current, and it goes down on the slope, like a turbulent current, and when it settles down, the heavier, larger grains going to the bottom, and it will become the so-called graded bedding. And the graded bedding, as I told you, coarse grain on the bottom and the fine grain on top. So this is graded bedding. The next one is the trace fossils. Trace fossils are really not telling you what kind of fossil we're talking about. However, it will talk to you about the environment. If you look at this slide here, what do we see? We see that there are like probably mud cracks right here. And we see these footsteps, and the thing which left the footsteps had 1, 2, 3, 4 finger, means it's quadruped. See, the other one had about 4, 1, 2, 3, 4 finger, so it's called footprints. Quadruped footprints, that's the way it goes. So we know that it must have been a shallow marine environment where some animal went to get food from the shallow marine environment, probably fish. So even though we don't know what kind of fossil, from the fact that there are footprints there, we can kind of tell what kind of environment this thing were forming. And this is also when you have animal burrows, usually these animals live on the beach, on the rocks, and they drill into it. Like they don't have little drill bits. They actually make the hole with some organic acid. They just eat out the rock, and that's how they go into it. And this is the fossil example. You can see how the clam went into the rock and made this so-called trace fossils, really, which is the fossil of the animal burrow. Animal is not in that, it's just the burrow. Now we are at the last important thing about the sedimentary rocks and the environment, and that is the maturity. Like when we say that a sedimentary rock mature, that means that it has been gone from its source area far, far, far away, and all the minerals are weathered away except for the most stable mineral are the quartz and the clay. So the quartz and clay minerals, those are the most stable. So if you have a sedimentary rock which nothing but quartz or clay minerals, then we know that this is really stable. That just means that it's far, far away from its original location. It went through from the mountain all the way to the beach, usually, and everything weathered away but the quartz and the clay. Very mature means that it's only stable minerals in it, has no rock fragments anymore, and it's all rounded. The sediments are the same size. And then we call that sedimentary rock is mature. So please remember this, it's really, really important.